I'm here to help you with your chemistry. Today, it looks like we're going to be tackling what's known as partial pressure. And so first off, the basic concept works like this. When you have a large number of gases all together in the same container, then each gas is going to have its own individual pressure. So if we want to know the total pressure of a container, it's found by Dalton's law. And so total pressure is equal to the sum of the parts. In this case, however, this problem is asking for something just a little bit different. It doesn't give us the pressures of the individual gases. Instead, it provides us with the moles. Well, using the same concept that total pressure is equal to the sum of all of those provided, we then have a different variation of Dalton's law, and it's this one right here, where in order to find the partial pressure of a gas, you take the mole fraction and you multiply by the total pressure. And so pretty much what it is applying a percentage, and that's it. A mole fraction is exactly what it sounds like. It's a fraction of the moles of the gas divided by the total number of moles. That gives us a decimal, which we can then apply to the total pressure. That'll give us the partial pressures of each of the individual gases. So for oxygen, looking at it, there's a grand total of 2 moles of oxygen. And when we look at all of the moles together, 2 plus 5 plus 7 gives us 14 moles of the gas. So if we take the partial pressure of oxygen times the total pressure of the container at 1519.5, we can then find the partial pressure of oxygen. Keeping it to 2 significant figures, since this value has 2, this value has 3, and this one has 5, our final answer can only have 2 significant figures. That means then that when we calculate the partial pressure for oxygen, it comes out to be 220 kPa. If we apply this same process for helium, helium has a grand total of 5 moles in the container. Still has a total of 14 moles of gas combined times 1519.5. And keeping it to 2 significant figures means that the partial pressure of helium would then be 540 kPas. Lastly then, for the nitrogen. Nitrogen has 7 moles present in the container out of the 14 that there are total, times the pressure of 1519.5 kPa, and keeping it to 2 significant figures means that we'd have 760 kPa for the pressure of nitrogen. So that's how this type of process works. I hope it helps, and I look forward to answering your questions over chemistry.